Hello, Natroners, and welcome back to VFX with Natron. I'm sitting here thinking to myself today, what would people like to know about? And it turns out a lot of people have a lot of questions regarding things about Natron that they're not familiar with, or at least they don't know the answers to. And some of the stuff I've always just assumed, oh, they must know it, they must know the basic ins and outs of Natron, right? Well, turns out that I was wrong. There's people who don't know things. Little tricks, little tips, things that can make things work better. And some people don't really understand what other things like, for example, clamp nodes are used for. So I thought I would make this little bits and bobbles a version of this episode where we can look at some of these potential problems that people run into. They're not problems, but things to help people understand stuff better, and that it'll help your workflow, and it will make a lot of stuff work better. So let's get over into Natron. Alright, so the first thing up on my magic little list, I wrote a list. Who knew I could write, right? Oh, you seen me spelling errors, I can't spell. Alright, anyway, we're here. One of the things that comes up is, first question a lot of people have asked me is, what's the real difference between a solid and a constant? And because I've used solids a lot of times in the past when I should have used a constant, and so forth. And if we sit here and we select one and we hit the one key, by the way, this is a tip. Apparently a lot of people don't realize that you'll, on your keyboard, if you use your numeric keys across the top of your alphanumeric keyboard area, that the numbers there represent inputs into a viewer node. So, for example, this solid here, if I hit the one key with it selected, that puts that viewer node, it connects up the viewer node to the solid node. And if I take and select the constant next to it, and I hit the 2 key, it connects viewer input number 2. And right now, there's really not much difference. If I go back to 1, oh, look at that. 1, when I hit 1, I connected it to the constant. Alright, so what we're seeing here is when you hit a key, it switches. Doesn't matter which key you hit, I can jump all around. I can have up to 10 different inputs going into my viewer node. Alright, and you can access them from numbers 1 through 0, or 1 through 9 plus 0, 0 being 10. So, for example, if we hit 0 here, we'll see it's input 10. The other thing this is useful for is you can do this comparison between the two. But before I show you what the comparison is, let's just figure out what the difference between the solid and the constant is, and this brings up a second tip. A lot of people don't realize they're used to using stuff like Photoshop or in some other programs that allow you to see when you're dealing with transparency in the background, you see a checkerboard. And a lot of people think that the way I would do that in here is I'd hit the tab key and I'd type in checker, and there's a checkerboard, and then I'd, throw in a merge node here. Well, I'd connect it to this because I want it at the bottom, so I'd connect it here, then I'd connect this up, and, there we go. We have something that we think would be a checkerboard. Except for this isn't actually accurate. This is not properly representing what's going on here. The reason the merge node is showing this as transparent is, well, yes, the solid doesn't have an alpha channel, but there's another thing. We are using 3 nodes to achieve what we don't really need. It turns out right up here, right next to this sRGB up here, which is the color mode for the viewer, obviously, we've gone over that in the past, there's this little checker. And if we click on that, you'll notice that this put, it made it red. red and grey. At least on my system, it may be orange and grey on yours, or whatever colours you have your Natron set up to. But what we do notice here is that the solid didn't become transparent in the background. That's because the solid is actually not transparent. It just lacks an alpha channel. And we've gone over alpha channels in the past. Solids not having an alpha channel by default shouldn't have transparency, and this shows that it doesn't actually have transparency. So the solid, and you say, well, wait a minute, or don't believe you, prove to me that the solid doesn't have transparency. Well, we know the big difference between the solid and the constant is that the constant starts with an alpha channel that's set to 0. So that means that while the solid is not transparent, the constant should be. So if we hit the 1 key here, lo and behold, we have a checkerboard behind it, which means that's the big deal, or the big difference between the constant and the solid, is that the solid is actually solid. It has no alpha channel. How can we make the constant solid? Well, we go up here, we switch this from 4 combined inputs. We could drag it all the way up, but we wouldn't keep all black. We could make it all white. And that would make it so that it's not transparent. But what we really want to do is hit this 4 so that we get 4 independent inputs. We get the R, G, B, and alpha. And when we get to the alpha, we just take the alpha up to 1. And lo and behold, now we've made the constant the same as the solid. But the reason that the solid with merge nodes looks like it's transparent is actually not the solid's fault. It's actually a property of the merge node. And let me show you this. This is actually very this is another tip. All right, so let's say let's just add a merge node here, and I connect the I'll connect the B into it. You know, we'll just use it at the bottom, and we'll notice that when the solid goes into the B input, we have black. We got a black image, even though it's solid in the background. All right. But when we put the solid on the top input, the A input, it's transparent. All right. Well, why is that happening? This is a property of the merge node. And how the merge node, you'll notice over here that it's saying that the output layer, the A layer, has no, let's just disconnect this for a second. You'll notice down here, the output layers, it has nothing down here. It just says, well, all it's doing is outputting RGB, and we have transparency. When I connect the solid to the B, it says the B layer is RGB, all right? It's just RGB, there's no A, and the A checkbox is disabled, but even if we enable it, it doesn't do anything. But the A, because A means above in Natron and B means below, A is trying to put this A channel or the thing that's coming in on the A input above whatever's on the background. Well, the background is empty, therefore it's got an alpha of black, and it's basically adding an alpha to it, because what we've told here, you can see that it's saying that the A layer is an RGB. It's not an RGBA. All right. If I check the A here, though, you notice I can turn on the A for the I channel, and it makes it black. Why? Because it actually has a hidden alpha channel. It's just not enabled by default. So it just ignores it, and so it's treated as transparent because it's trying to put it up here. Now, I can also disable it on the output, because the output is right now the output set so that it outputs an alpha channel even though it has no alpha channel coming in. So it has no alpha channel coming in, so no alpha channel is 0, which means it's black. So I click this. Oh, wait, it's still doing it. All right, well, we have to do it here. Wait a minute, it's not doing it. That's because the alpha channel, the merge nodes don't work exactly as one would expect. It is, you need to make sure when you're outputting that you enable both, the alpha on both, and that will fix the solid so that it represents itself on the top node. All right. Notice when I connect up the constant here, we can we'll disconnect it again, and when I connect up the A to the constant, it's not doing it because we manually overdid it. Oh, we overrode that. Oh, now we've screwed up the merge node. One of the problems with Natron sometimes is that if you do modify things, it throws them off. Anyway, this was tip 1 through, I don't know how many. We've looked at the fact that a constant has transparency by default unless we change that alpha, and we can see it with the checkerboard, which is pretty cool. Oh yes, and this does also raise one other thing that I want to point out. Actually, let's I shouldn't have deleted that merge node. I want that back. Come back here. We're going to undo until we get it. Alright, so here we go. We've told it we want to have transparency. We're going to connect A to the solid, B to the constant, and then we're going to put something into the mask, because people also don't understand what the mask does. Well, the mask is just a transparency. It's putting in an alpha to the input on the side. It's using it. It's just a way of blending instead of using this little wipe here to go back and forth between the two. What it's doing is it will, and again, just remember the constants on the bottom, and the alphas or the solids on the top, and they're all both being told to use alpha channels. So that's why the solid is showing up as opaque. So that's why when we drop this down, it turns to checkerboard, because the constant doesn't have an alpha at the moment. Alright, so if we put in something else, let's put in an SE noise. Alright, an SE noise. If I take that and I put that into the mask, you'll notice that the SE noise is also transparent. The black in the SE noise is not actually black. It's alpha. It means that the SE noise, by default, if we look at its alpha channel, is there's information there. There's only white. There's white and black, which means that it's transparent. So when we use it to merge between the two, it actually works. Whereas if we told the SE noise that we don't want alpha, well then notice that it doesn't. We wind up with the checkerboard down here because we removed it. And anyway, I just wanted to show that we can use the SE noise. And this will lead to something. Remember that. Remember that about the SE noise, because next Saturday you guys are going to appreciate that one. Alright? It's going to make a whole lot of sense. All this stuff I teach you, it has purpose. Alright, so let's see. I want to also point out another thing while we're still here. Let's take this, connect it back up. Let's turn that SE noise back to its regular default so we use it. Now, somebody else told me that they didn't realize is that the whole concept of, for a lot of times, everybody knows you can scrub here back and forth with these sliders, but apparently I haven't made it known much that if you depending on where you click in the numeric area of any given digit area on Natron, anything, even if it doesn't have a slider, if this was just numbers, you can actually turn it into a virtual slider. And a lot of times, at least with the native nodes, you can push those numbers up and down using your middle scroll wheel on your mouse. So for example, if I put this in the ones digit place on this triple digit, it says 455. If I put I have it so I'm just to the left of the ones digit, okay, and either that or I select the ones digit and I scroll up. You can see it change. Well, my mouse is over it. I scroll up and it increases it. I scroll down and it decreases it, and so it's changing the ones digit. So I'll put it back to the 5. Whoops, we'll put it back to 5. Now I'll select the tens digit, All right, or actually, this time I'm going to put it to the left of the 10th digit, and I scroll up, and now I'm moving up in increments of 10. And as you can see, our noise pattern is increasing. I decrease it by 10 by scrolling down. Let's move it back up to 455, and let's go up here to the hundreds digit, and then I can take the hundreds digit. We start off at 400. I go up 500, 600, 700. Then I go down. And as you can see, so whoops, we went too far down and we created an error. Oh, well, why did we get an error? Because we went negative. SE noise does not like negative numbers. It produces things called NINs, which are not a number. That's what NIN stands for. And you'll see it, that's what this little error up here is. And you'll notice that the reason it's not a number is because SE noise is based off of this thing called EXPR, or SE expressions, which was created by Disney, by the way. And a lot of Natron stuff is built around this SE noise, or SE expression language. It's a VFX language. Anyway, so we say, oh, this should be easy to fix. We'll put it up to a positive number, and we see that, we still have the error. It didn't clear. It's still giving us a warning across the node that had the problem. Well, this is your next tip. I've used this tip in the past, but in one of my earlier episodes, if you hold down the Alt key and you hit the P, that stands for turning on and off the preview of a node. Any node, you can turn it on. Or if you have multiple nodes selected, if you drag around them, like so, I just dragged around all 4 of those. We can drag around these upper 2, or we could drag around these ones. If we right click in our view, we can see under, I believe it is, right, where is it? Previews. Toggle preview images is Alt P. All right. So we hit Alt P, and notice when I hit it, enabled the preview windows on the nodes, it disabled, or it cleared that warning. So long as the warning or the error, it'll either give you warnings are yellow, errors or red. So as long as the error is no longer, or warning or error are no longer in effect, by hitting Alt P, and it doesn't matter whether it's viewing or not, by hitting Alt P, you can clear it. All right, so I can just hit Alt P, and as you can see, Alt P enables them and disables the preview. So there's another tip. Let's see, we went over that one. Scroll wheel. Okay, the ROD. So, a lot of people have heard me use the term ROD in the past. What the heck is an ROD? It says down here below our viewer node, it has this thing that says ROD. The ROD is the region of, I believe it stands for region of definition or region of domain. It is the size of a given input, a given thing. It does everything that you combine together inside of Natron is made up, has to have a render region, and sometimes you want that render region to be bigger than what your output resolution. So right now our viewer is set to output at HD, which means 1080p. All right, that's what this HD right here is, and that's what the default is. HD is 1920 by 1080. All right, and if we go up to solid and we select it, this solid is also set to, we'll notice it says here, extents are default. And what that means is it's using the system, or the project size, or at least, or that's what it's supposed to use. And where's the project size? Well, if you hit the S key, you pull up your project size, and it says that the output format right here, and it has a list of output formats. And you can change it, you can add a new format if you want, but by default, it defaults to 1080p. We could change it to 4K, and you'll notice that the solid, because it was set to default, automatically updated to whatever the project size was. All right, I'm going to switch it back down because I almost always work in HD resolutions. All right. Now, there's another thing that we should know. Oh yes, and also on the project, on this project settings, this is where you set your frame range for your project. And you hit again, S key pulls that up. All right. And you'll notice you can also enable and disable your GPU rendering here, which can save you a trip to your preferences if you didn't know that. All right. So let's turn that off. I want to show you an example of a situation where we would see this, which is text nodes. All right, so we're going to go text, and we're going to pull up a text node, and you'll notice, the text node is also transparent in the background. But the text node is a little weird. We'll notice that the text node has a source input, but if we directly connect it to the output of something like a merge node, it doesn't actually register whatever's coming in. All that source input is used for is setting up, is using feeding it an input so that it can change its size. That's all it's used for. It actually isn't used for anything else. It is not an actual, in order to composite the text node over something else, we have to feed it into the A channel of something, like so. So we could put, if this was in here and we were to view this, and I'll put this over it, it still doesn't look like it's working. In fact, actually it is working. We're seeing little bitty, the noise is combining it. But we want to actually put it over it. Well, let's try and put it over it. And there we go. We've put it over it. It's weird. It's actually all of these are being influenced by that original, by this SE noise and composited with the constant. Anyhow, but the reason I actually came over to the text node is because the text node has a thing here that's called auto size. I rarely ever push this auto size button, but it has a lot of very good uses. Let me show you an example of something where this is really useful. Let's take our font size. We'll bring it all the way up to 500. All right. Now, this is another area where it's useful. Our font size only has a scrubber that goes up to 500. But if we go over the 500 mark and we scroll up, we can bring it up until it's really, really, really big. Huge. And then we say, oh, that's exactly how big I want my text node to be. And then I put a transform node. Whoops, no, a tab T, sorry. T key. As long as I hit the right key, we get the right response. Alright, so T. Why did we put a transform? Because we are transforming something. We're animating it, or we would be animating it. And I want to shrink my text down to fit into this view, because my goal here is eventually to scale it up bigger than my view, and I don't want it to, I need it to be big because I don't want it to pixelate when I make the view bigger. So I'm going to take my scale here and I'm going to bring it down, and the first thing we notice is uh-oh, that doesn't look right. And for right now, I'm actually going to turn off the checkerboard so we can see here. I don't know if you can see it here. It says 382 by 214 right here, which is the bottom left corner of, that's the bottom left corner of this text node area, okay? And up here is the upper right, the top right, okay? This is bottom and left, this is top and right. And the ROD is broken down that way. It's the region of domain. It is how much space this currently occupies. With our HD output, what our ROD would be is it would be 1920 by 1080. See, there's 4 digits there. That's important to remember, because when you call or when you look up with an expression ROD information, or the size of your output format, you're going to work with the size. You have to know the bottom left, the bottom, the left, the right, and the top. Those are the different things in expressions. That's how you would get it for your output format. So the problem here is, okay, well, this doesn't do us any good. This is where this, I want to pull up the text node here. This is where this auto size becomes useful. We've shrunk it down. Let's shrink it down a little bit more, get it nice and small. Auto size is going to do something here. It's going to shift the entire thing off, and you'll notice that it's like, what just happened? It's all wonky. It's gone weird on us. We're not where we expected to be. Everything looks totally wrong, except for one little bit. We can, if we look at our transform and we start transforming this off to the side, that one, that doesn't matter. We can, we'll take this off. We'll get it, zoom it off to the left, more and more. So there we go. We've pulled it off to the side, and we can see the entire text area, because the text area, when it's scaled to 1, when you use auto size, it scales it up. But here's the thing. Let's disable this. You'll notice that the center point, when we originally set up our text node, that it was set to center interact, and transform was on. So it had that at the center of our view area, which was 1920 by 1080. See, here's our ROD. 00, 1920, 1080. All right? When I turn off center interact, we're in the top left corner of the ROD for that text box. All right? So when we tell it, when we say auto size, wait a minute, what happened here? It went back to the center of our view of our current ROD, because our ROD, by default, what the center here is for the text area is set to 1960 by 540, because that is the default, that's the halfway point for HD resolution. So we can reset the center of our text area. If we zoom out, we can see at the actual full size. This is the ROD. This dotted line is the ROD for our text. All right. Whereas this down in this bottom little corner is the ROD of our output. That's our output. That's what our viewer is actually displaying. All right. So that is what ROD is. It's the size of something. And if I tell the text node to reset its center point, okay, what it's going to do is move this interactive center point of the text node off to the center of its ROD. All right. So watch what happens. I'll hit this, and lo and behold, now that the text interaction happens at the center point of its ROD. And anytime the center point always stays consistent. It stays wherever you last set it. So if I change my scale back down to, whoa, that's not what I meant to do. If I change, let's re-enable our transform. You'll notice that it's shifted over, and now our text or our transform is off to the right here. And it's a wee bit, oh no, we didn't actually reset the center of the transform. The transform kept its center off where it originally started. So we need to reset its center as well. And there we go. And then you'll notice that Natron automatically updated its translation and its center point area. So now we can move it around and things start working. So understanding that we have I had the center point of my text field, I'll have my center point of my transform, and this is the RODs, this area around it. That's how much is, if you make that ROD too big, you'll run out of system memory, and if you have too many really big things, it really gets into problems. So if you're working with, like, here's an example. Let's say you were doing something really big where you had a single letter just transforming across, like in, say, Stranger Things. Oi, you've all seen the show Stranger Things where they have those big letters and so forth. Well, they don't actually want to have that big letter showing up on the screen at one time. They would just show that individual letter or a few of the letters, and they would set the ROD for that letter only, and sometimes they make it even bigger than that letter if they need to, if they have to. There's ways of increasing the ROD. Anyway, I don't want to go any further on that. That's ROD. I've talked about the 1 through 10. Oh yes, timeline. So you've done, inevitably people have done this. If you're over your timeline and you scroll in and out and you pan, you can zoom in, zoom out, get everything all wonky and all over the place, zooming around on your timeline. And then you say, oh my goodness, I have no idea where I am. If you right click in your timeline, what it does is it sets the left hand side of the screen or the left hand side of the timeline to your first frame, the right hand side of the timeline to your end frame, or at least what is set to it. But you'll notice it's a little wider than it was when you started. If you go over and you take your center mouse wheel and you just scroll in one bit, you can get it back so it looks more or less the same. Do know, however, this will not auto size anymore. It used to auto size based off of things. It doesn't do that, but you can also do things like you can change your out frame. I just changed my out frame here to 1. If I set this back to 250 and then I click this, whoops, I didn't mean to do that. I want to go to the end, 250, and then I want to hit that, which should, oh come on, let's put this back to 250. And then we right click, there we go, alright, there we go, we have it back, and we could do the same with the first one. This just sets you in and you're out. Alright, so there we go, we fixed that. Next thing, alright, we've got that. Curves, that's something that I thought I was going to be a lot further along than I am, but curves, let's do some little bit of animation. So, I'll take my animation here, I'm going to go to my very first frame. I'm going to put for this transform, I'm going to set a key for all dimensions, and then I'm going to go to my last frame, or close to my last frame, and I'm going to drag this over and up, and then I go over here and I have 2 curves. Oh, this isn't what I wanted. I wanted this to be mirrored. I want to actually, you know what? I should use something that actually would benefit from that. Let's go into our text node. Our text node, we have colors. Alright, so let's see. I want to change over time. I want to change my red, all these things. I'm going to set a key, all dimensions, and then I'm going to go ahead in time to way up here, and I'm going to just say, oh, I want the font color. I want my red to be, you know, 20, and I've set it. Oh, actually, that's not good. Let's set it down to. Let's set it low. Alright, let's set it to, alright, that's -70. That's fine. Alright, we're fine. We say we want it to be just like that. Actually, let's set it to 0. 0. I didn't want it to be there. I'm going to set it to 0.2. Why? Just because. Alright. So I go into my curve editor. I want to get to my fonts. I hit F to fit. F, by the way, oh yes, that's another thing. If we're zoomed in, zoomed out, and you hit F on your keyboard over a view, and either the view for your viewer node, it fits your viewer node. If you hit Control 1, it sets it to a 1-to-1 ratio. So F fits, Control 1 sets it to 1-to-1. Again, fit. Alright. And likewise, if we're zoomed in on a graph, and we hit F, we fit our graph view both horizontally so that all the animation fits into the of whatever selected fits within the current view. So right now we have an animation on our red channel. All right, I'm going to select these things. Oh no, actually, you know what? It would be really easy to make a linear animation. So we're going to do something really wonky. Who cares? It doesn't matter whether it's this isn't right. Let's see. I didn't want it to be there. Or can I make that? I'll just make it something really weird. All right, let's say that's what we wanted our animation to be. I select this. I select all my keys by dragging a box around them. All right, and the way I drag a box is I just click in an area where there's nothing, and I drag around it. I hit Control C to copy. I go over to my green channel, and you can see my green channel doesn't have anything. I select it the way you select a channel. Is you see how the blue is currently yellow. Don't ask me why they color coded it that way, but we select this yellow, or it's actually like a line more than anything, but it turns yellow. Let's go back to the green, which is orange. You can see this, or is the green is orange. When I click on it with my mouse, it turns yellow. That means I've selected that curve. All right, and that's important because when you hit Control V, you're going to be I copied the keyframes or the curve from my red channel, and now I'm going to hit Control V and paste it onto my green channel. And lo and behold, it now matches my red channel. So I can go down to my B channel, my blue channel, select it. Oops, I added it doesn't matter that I added that. Watch this, Control paste. Oh, look at that. It didn't do what I wanted it to do. It shouldn't have done what it just did. Let's go back there. Hold on. Ah, everything's all wonky. I deleted the channel. Whoa. I didn't want to do that. Oi, we didn't mean to do that. Let's set key for all dimensions. And now I've screwed it all up, and so we have to rebuild this. We have our fudge. Well, hopefully we can Control paste. Oh, look at that. Oh, I still added in the memory. Select my green, Control paste, because I had it in the memory. Select my blue, Control paste, had it in its memory, and we're not going to mess with the alpha. We're going to keep that one. And lo and behold, now when I hit play, we can see over the course of our animation it's dimming down because setting all the values to match means that the colors will change between shades of gray. So there we go. So that's copying, pasting curves and keyframes. Let's see. We've done that. The only thing left is the big one. Let's see what time. 37. All right. I made a special thing. So we're going to talk about clamp nodes quickly. This is the last thing. If we look at these, I'll have a whole bunch of solids here. Solid 1, solid 2, solid 3, solid 4. They're all white, right? Well, that's nice. I want to merge these two and do a difference. Because what difference does, let's hit merge. And I'm going to take this and I'm going to put solid number 2 over solid number 1. And I'm going to set it so that it shows me the difference. Now, we have two things that are white, right? We saw they're white. Let's just verify this. White, right? We see white. That's what we're seeing. I go over my merge node. I tell it what to take white and subtract white from white. Well, white and white should equal, if you subtract if white is every color, and you subtract every color from every color, that means we should want with black, correct? Why, of course, that just makes sense. All right, let's do it. We go over here and we say difference. And wait a minute. Wait a minute. I shouldn't have done it. Oh, excuse me. I want to divide it. Right, is that right? Yes, I want to. Oh, wait a minute. Yes, divide. I want to divide 1 from 1. Which should give us 1. Is that right? I don't know. Wait a minute. Divide. No. I've got something totally wrong here. I know. Why is my difference not working here? Let me just look at this. Oh, I know why. Silly me. We wound up with... Oh, it is working right. All right. That's fine. Let's take... Sorry. I did something ahead of time. I get silly with myself. All right, here's a white. Let me make sure this white is white as well. All right, this is the white I want to use. All right, white. Let's do a difference. Ready? Here we go. And what the heck? That's not what we wanted. Why did we wind up with purple? We should have wound up with white, just like this. This worked the way we expected, but this one didn't. Even though my source says it's white, this source says it's white, this source says it's white. Okay, well that's weird. All right, let's see. What happens if we connect it to the last one? Whoa, we wound up with a totally different but that's white as well. What's going on here? That's not what we expected. In fact, I got something I wasn't expected here. Let's draw something different. Let's go here. Let's connect it up. Oh, we wound up with the same thing there. What if we did? What the? We wound up with white out of that? But we started with white. How can we do the difference of the two and still wind up with white? This isn't doing what we're expecting. Why are we winding up with these values? And it's actually pretty simple. The problem is, these, some of you probably noticed, are not actually white. They're beyond white. They have values that exceed white. Here we can see the blue channel is set up to higher than white, and the blue channel, let's just check this one. Oh, this one. All right, let's go over here. Let's for a second take this one and this one, all right? And we're going to just take one of them down to 1. As soon as I take the one down to one of them down, the blue channel is down to 1, we wind up with blue, because the difference says that we're taking the one from the other, but we still have a remainder of 1 blue. Well, that's not what we wanted. That's not what it looked like before. That's, well, now it's, well, that's weird. It's just not right. We're not getting what we expected out of here. Well, how do we fix that? How do we take the inputs and guarantee that what we see before the merge node is what we get? It gives us the proper result when we get out of that merge node. Well, the easy way is obviously we put a clamp node. See, whoops, oh, it didn't hit tab. Clamp node. There we go. We put a clamp in there, and we'll go over to this one. Whoops, we'll tab. Clamp node, and then when we go down here, lo and behold, we get black. That's what we wanted, right? All right, now let's add another merge node and take a look at this other one over here. All right, we're getting 1 here. That's exactly what we wanted. Oh wait, no, we haven't done a difference. All right, we say difference, and seems to be giving us a 1. Why did we get 1? That shouldn't be giving us a 1. That's weird. That should be giving us something totally different, but it says it's the right thing. All right, we're going to just accept that that's correct. All right, let's go over here. Let's do a merge. Let's take a look at this one. Huh, that one's working as well. Why is that? That shouldn't be working. That should not be working. This should not be working the way it is working. This has a green and a blue of 3 and 4, which means that if we were to subtract this, take the difference of the two, let's look at this. Hold on. Huh, that's weird. I'm going to show you how what's going on. We're getting really wonky results. I expect things to do things that they're not doing. So why are we getting the results? All right, let's take a look what happens when we get rid of those clamp nodes. If I scroll my mouse wheel over here without even looking at these, I don't want to look at those at all. We're not going to cheat by looking at the actual properties. If I look over here and I scrub around on top of this, you can see down here there's a red, green, and blue number here, and they say 111. If I go over to this one, you can see it says 112. Here it says 411. All right, so that means that this one has 4, this one has 1. Excuse me. This one has 2, excuse me, over here. So what we're going to wind up with is a result that's still higher than 1, but it is not higher than, or it's still off, if that makes sense. So it's going to, even though we can wind up with a result down here that looks white, this still looks white, but we still have actually a wrong number here. Look at those numbers. We actually have 332, and that's the problem with Natron. Natron will show us all the values that we want and so forth, and you're saying to yourself, well, this isn't a problem, we're still getting a result. Well, we're getting a result here, and if we rendered this out, it would give us a nice result, But let's do something like put in that SE noise. Let's draw that, and we're going to put it into our mask. And it's not going to show us. All right, let's just do this one. Still too much. All right. Let's drop you down a bit. Instead of 4, let's drop you down to 2. All right, it's not going to do it because it's not the top node. There we go. All right, now we're starting to see it. Look at this. This is very weird. When I take the SE noise node, which we know is transparent, and I pipe this white through it, it's white up at the top, and it should be, we have nothing going into B, so it should be transforming into nothingness, but it's not. It's transforming into a pinkish color, a reddish color around the edge. That's very weird. Over here, we have something that, if we look at the colors, we have greens and blues, and we wind up with something that's cyan. And over here, we wind up with something that's blue. And here we wind up with something that we expect. This we're beginning to see. And actually, let's just show that we're actually going to transparency with this. So this one is blending correctly because this one is all 1-1s across. This one is doing something weird. It's going to this. It's going to blue, and then to blackish or to transparency as it goes down. Well, that's very weird. And here we're going to red and then to transparency, which is again weird. That's not what we're expecting. And then we're going over here to this one, which is cyan. It's just a total utter mess. We didn't want these things to happen. We had white in all of these things, but they're not really white. They're colors beyond white that are still colors. And what happens is as soon as we start transitioning through transparency, through alpha values, through those colors, we start recreating colors that we didn't think existed beforehand. Now, this can be beneficial. This has some benefits to it. Let me double check more time. Just make sure we're not going too long. Oh, we've gone long. All right. I'm going to wrap this up here. We're actually going to get into this more in the future. You solve this by putting clamp nodes the way, watch this, as soon as I put a clamp, I'm just going to put a clamp node here, and lo and behold, it fixes it. I'll put the clamp node over onto this one, it fixes it. I'll put the clamp node here, it fixes it. I'll put the clamp node there, it fixes it. No longer do I get colors, I get exactly what I expected out of those particular nodes because I clamped it. And the same goes from the results of your nodes as well. This, we clamped that one. Let's just for a minute take this in there. We wound up with blue here. Watch this. If I put the clamp node, I'm just going to do one more thing with this, which is I'm going to pipe this in here. When I clamp this, we wound up with black. That's interesting. That's not what we expected. We had blue, but we went to black. Why'd that happen? That's because our clamp node's working within a value of 0 to 1. Or at least it should have been. Wait a minute. This is, no, it should have. Am I working on the right one? Don't worry about it at this point. The point is that you can get it. You should, well, don't worry about it. It's, we ran into the situation. We're done. We're going to call that it. All right, let's go. Oh, yes. Hopefully that we haven't had any dropouts. I don't see any dropouts on the stream. It turns out the other day, there was something I just wanted. This is a last minute, nothing to do with the stream. You can turn this off, but I just wanted to point out the last stream, you noticed everything went really wonky. We had lots of dropouts, even after Thomas. Turns out there was something really big going on. There was SpaceX was going on, and there were a lot of apparently protests that went bad on Saturday. So there was a lot of web traffic, and we think that may have caused the problem. And it seems now everything, because I'm using the same program, everything seems to be going well. I'm hoping that I don't see any drop frames. It hasn't told me. I hope it's all been good. Keep on natroning. Let's just go over here. Keep on natroning, and I'll see you on Saturday.